Hello, my name is Matt Barlow. I am a cloud infrastructure lead at StratusGrid, and today I'm going to be talking about how to configure the memory for your Lambda functions. There are a few variables at play here when we think about assigning an amount of memory to a Lambda function. The first thing to keep in mind is that the more memory you allot to the Lambda function, the more CPU and network I/O is also going to be allotted. And the second thing is regarding the cost of running a Lambda function. The cost is going to be dependent upon the amount of memory that you assign and also the time of the invocation. And where this gets interesting is that you could have a function where maybe you only assign it 128 megs of memory, but you're actually paying more than if you were to upgrade that to 512 megs because the invocation time may be longer with the less memory that you have assigned to the function. So that's a lot to keep in mind, but we're going to use a really awesome and valuable tool called Lambda Performance Tuning to visualize our Lambdas as we have different memory assignments to them. So the first thing to do is to go ahead and install the components for AWS Lambda Power Tuning, and the easiest way to do that is using the serverless application repository. So this is going to install all of the components for the power tuning application into AWS. And it's going to do that using CloudFormation. While we're waiting for these resources to be created, I'm going to go ahead and clone the Lambda Power Tuning GitHub repository. And the reason that I'm cloning it is because there's a script that we're going to run in here that's going to actually kick off the state machine to run our evaluations. It's in the scripts directory, and there are a couple modifications that we'll need to make to the script and the input for the script. The first input that we're going to have to provide is the name of our Lambda function, or the ARN of it. So I have an example Lambda function that is super simple, and we can go ahead and invoke it locally, see that it returns very quickly. We're going to start with this, and then we'll run the performance test again on a more complex Lambda. I'll go ahead and deploy the Lambda, and that will give me the function ARN as output. Now that I have the function ARN, I'm going to go back into the Lambda Power Tuning script directory, and I'm going to open up the inputs and paste it in. The second thing I need to change is the name of the stack name. This script is going to pull from the outputs of the stack, so I need to make sure this is updated. Now that those things are in place, I can go ahead and run execution of the state machine that's going to run all of the tests. We can see the output here as the URL, And this is going to show us the results of our performance evaluations. Before we take a look at this, I'll point out that there's no data that's sent to any external service. All the data from our tests is encoded in this request parameter here. So on this graph that was created for us, the blue line represents the cost and the red line indicates the invocation time. So as we might expect with a really simple Lambda function, the more resources we throw at it doesn't really affect the invocation time very much. It does go down slightly at 256 megabytes of memory, and we can see up here that that was our best cost. So if we were operating on production Lambdas after this test, we might conclude that 256 megabytes is a good setting because it gives us not only the lowest invocation time, but also the lowest cost. Now let's run this again with a more complex Lambda. So we can see that this Lambda takes significantly longer to run, and it's going to be much more CPU intensive. I'll go ahead and deploy our change. And then I'll go ahead and run the Lambda power tuning against it again. While this is running, let's take a look at the step functions. And it looks like it already finished. Now these results look much more interesting. We can see now that with a more CPU intensive Lambda function, the more memory that we're allotting to the function, the shorter the invocation time. And it's a pretty significant difference, going all the way up from 18 seconds for 128 megabytes down to less than 2 seconds at our maximum configuration of 3008 megabytes of memory. We can see that the best cost is determined to be at 256 megabytes when you take into account the invocation time and the memory allotment. But if we were really wanted to optimize just for speed, then we could continue to raise the memory, and we can see it decreases the invocation time significantly. So that concludes my demonstration of optimizing the memory configuration for your Lambda functions. Please check out the notes for this YouTube video for links to other documentation that can help you get started yourself. Thank you.